So good afternoon, dear students. Is my screen visible and am I audible? Somebody please respond.
Yes, sir.
Yeah, thank you. Welcome to another session on Introduction to Data Structures and Algorithms. Today we are discussing in Module 3 deletion and searching of linked list. Okay, in the last class we discussed about insertion, creation of a linked list, insertion of linked list, and today we are about to discuss on the deletion of nodes and searching of nodes in the linked list. So what is exactly deletion operation talks all about? The deletion operation mainly used to remove an existing element from the linked list. Of course, there are a couple of tasks that are to be performed while deleting the linked list. First one, you should know the location of the element, which one you have to delete. That is the first condition. Second is the element value. First you have to traverse, you have to retrieve the value, you have to search for that value, so that you have to delete that value. So that is
Wow, bete, wow.
one very important thing that you have to understand. And of course, the link pointer of the previous node has to be reset. For example, if you are trying to delete the first element of the linked list, so the link pointer, of course, after deleting, where it has to go, so that you have to reset. These are the three major things that you have to do. And of course, the searching element which you are looking for deletion, so there are three possible scenarios. First one, delete the element at the beginning of the list. There are chances that the element may be available in the first node itself. So you should be prepared to delete the first element of the linked list. And of course, there are chances that the element may appear at the end. So when it appears at the end of the linked list, so the last node, how to delete. And of course, in between the first node and last node, if the element is found, so you have to locate it and you have to delete it. So you have seen insertion operation in arrays, and you have seen insertion operation in linked list. They are totally different. Similarly, the deletion operation also. Okay, so let us take this example. Consider this example. Suppose you are trying to delete an element which is available in the first instance itself. So you can see the element is present in the first instance itself. So if it is present in the first instance itself, so here itself it is present. So, and what happens? You have to move this head which is pointing to the first node. You have to move this head to the next node, that is node B. It has to be moved, and this node you have to delete it. Delete in the sense, so just like how you allocated the memory, the same way you have to deallocate the memory. So after deleting the first element, the head node will point to the next. So this is deleting at the beginning. Deleting at the beginning. So that is what you should understand. So deleting the node at the beginning indicates movement of head node to its next node. So the red color one which is marked is the element that is to be deleted. So if you want to delete the first element, so what happens? You have to move the head and you have to delete this particular node. this particular node, I can call it as temp node. So temp node, you have to start from the beginning. If the temp node TMP, that is temp node, is available in the beginning itself, so what you can do, you can deallocate. Deallocation deletion function you know very well. So free is the command. I think malloc is for allocation of memory, free for releasing the memory. That means the entire linked list which is allocated for this, you can free it out. Anyhow, we'll see that example in the implementation of C program. We'll discuss that. Okay. So deleting the node at the middle. So what happens? This is TMP starts from here. TMP node, it starts from here. Whether it is the first node, it is checking. No, it is not 12 is not equal to 18. Next element is 18. Yes. What happens? So when it is 18, so what you have to do, you have to move this, the previous link of this, you have to move to the next link. So you have to move to the next link, and you have to delete this link, and you have to delete this node. That means you have to free this node. So this is how you have to do the operation. So you have to delete the node. Before deleting the node, what you have to do, the previous node's next link, you have to connect it to the next node of the TMP, that is current node. So by doing so, what happens? The link is established, and finally you can delete this node. So node B, you can delete it. So that is how you can certainly understand how to delete it. Next, deleting the node at the end. So what happens? So you are given an element which has to be located, and if the element is found at the end, so deleting element is 47. Just imagine it is 47. So it starts from the beginning node. Is 9 is equal to 47? No. Then it goes to the next. Is 35 is equal to 47? No. Next it moves. If 47 is equal to 47? Yes. So in that case, what I have to do, this particular nodes, the next link, whatever the next link that you have, that is null, it has to be attached to the previous node. So previous node, you have to attach to null and delete this node. So that's the thing. The current nodes, current node is this one. Current node's link is equal to the previous node link. So previous node's next link. So you equate that and you delete the current node. So that is the logic that is involved in deletion of nodes. The same program, it is we can certainly do it using C program, and of course the program is like this. So I just open the C program. Okay, you can see initially what you are trying to do is you are trying to create a node. So this is the structure. So struct node, integer data, struct node star next pointer always points to next. So with this, what you can do, you can create a linked list node. Okay, one node is created. Now insert function I have already set. So here for insert function, head node I am using pointer to pointer. Yes, that means whatever the head node changes, automatically that will be incorporated, right? So the new data, whatever you are getting in, so for that data, what you are trying to do, you are allocating the memory, putting into a structure, and you create a node, new node, and new node data is equal to whatever the data that you have sent, and the head is equal to new node. So like this, you keep on adding in the front. So you keep on adding the node in the front. So that is done, and head is equal to new node. So head moves to the new node. So every time you add a node, so it goes to the front. So it goes to the front. So we'll see that how exactly this thing will work. Now next, delete. So for this you are passing head and you are passing deleting value. So it has to find this deleting value, and based on this deleting value you have to delete. Okay, now there are cases where there is only one node. There are only one node, single node linked list. Now look at here. So for this you are using a temp. Temp is to move from one node to another node, one node to one other node in search of the deleting value. And every time it moves, the previous pointer is also used. Previous pointer points to the previous to the temp node. Okay, we'll see that how exactly it works. Now, if temp.next is equal to null, if there is, what is the meaning of this? There is only one single element. There is only one single element in the linked list, and the data value matches. The data value matches. In that case, what you do, you make head is equal to null. That means head is pointing to null and free the temp. Temp means the existing node will be deleted. So the deleting value it is showing, it is the del value. It is just displaying this particular element got deleted. So free is a function to remove a single element. Even though it is a single element linked list, so you are going to delete like this. So by moving head to null indicates that no element is there in the linked list. So that is an indication. Suppose if the head node itself is the node where you have to be deleted. Suppose you see, if temp is not null, okay, temp is not null, that means temp is not null, the current node is not null, and temp data is equal to del until you reach the end of the linked list, and if it is not if it is equal to the deleting value, so you keep on checking. So you look at here, if so head is equal to temp of next. That means if the first node you are trying to delete, and the data is found in the first element itself, and what happens, the head you are moving to the next cell. So that's what you did in the diagram that you have seen. So I think in this diagram you have seen. So if you want to delete the first node, what you did, you moved head to the next node. So same thing you are doing, head you are moving to the temp of next. So temp is present here, temp is present here. This head which was pointing to the first node, that is temp, is moved to the next node, temp of next. Temp of next is nothing but this node B. It is moved, and now what you did, print up the deleting values del and free the temp. So first step, what you did, you moved head to the temp of next, and later what you did, you deleted the node. So you should understand this concept. So very simple. This is the first task you did, and first task you moved the head node to the next node, and later second task what you did is you deleted the thing. So same thing here, you can see this is the first task, you are moving a head node to the temp next node, and later removing the existing node if the element is found in the first element, that is in the head, if it is found in the first head. Now if it is found not in the first place, somewhere in middle or somewhere in the end, so what you have to do, you have to traverse while loop, put a while loop, and run until, that is while loop, until the temp reaches the null, or you find the value until temp reaches the end. Null, not null means end. You keep on searching, you keep on looping. If it is found, you can just come out. Okay, so what happens? You are trying to, now previous node is equal to, previous is equal to temp. So what happens if you want to move to the next cell? So move the previous node to the previous node to the previous cell, and temp you move to the next, and check next again. Is temp is not null, and temp data is equal to del value. If it is not del value, if it is not equal, then you move again. You move the previous pointer to the temp, and temp is equal to temp of next. You move. So it is just like that. So in this example, look at here. I just clear it off all the things. Now, one second. I erase everything, erase all. Now, look at this particular example. So now temp is present here, and your deleting value temp is present here. So your deleting value is 18. Until you reach 18, or until you reach end of the linked list, you have to keep on moving. Check whether temp is equal to 18. So temp data is 12. 12, is it equal to 18? No. So in that case, what happens? It will do one simple thing. Previous is equal to temp. It moves the previous. So here the previous is moved. So previous is moved here. So I just write it as previous. Previous is moved, and this temp is moved to the temp of next. So that means it will move to this position. So temp is moved to this position. So earlier temp was present in 12. Now it moved here. So now is temp of data is equal to 18? Yes. Then what happens? This condition fails. This temp while condition fails, it will come out. Once it will come out, it will check whether temp has reached null. If it is reached null, it is indicate, so the temp has moved to the end of the linked list. That means there is no value that you are looking for. Deletion is not there. So value not found, that message it will give, and it will delete. It will return. In case if it is not reached the null, so it has found. So temp has moved here, previous is here. So what you do? Previous of next. That means previous, this previous is here. Next, previous of next, this position, this part, previous of next is equal to temp of next. Temp of next is node C. So this will be connected to node C. So this is the first task that it is going to do. It is going to do. So previous of next is equal to temp of next. So previous of next is equal to temp. Temp is pointing to node B. So node B of next is node C. So it will move to the C, node C. So node A's next is equal to node C. So that is what you are doing. And once it is done, free the temp. Free the temp. Free the temp means you delete it off. So after you delete this, automatically your node after deletion, the linked list becomes like this. Linked list become like this. So that is the thing. That is the thing that you have to understand. So if it is the last node, suppose if it is last node, so you are trying, first I'll clear this. So you are looking for an element which is 47. So what happens? There are two nodes, two pointers. One is TMP, temp pointer, and so check temp starts from first node. Is temp is equal to 40? If temp of data is equal to 47, no. So what happens? Temp will move to the next cell. Before that, what happens? It will move previous here. So previous is pointing to the previous that is node. And what happens? So what happens? Now temp points to the next node. So temp is pointing to the next node. So it is going to point to the next node. So it will point to the next node. So now it will check whether temp of data is equal to 47. No. So then what it will do? It will move this. It will move the previous to the temp. That means this node, that is node B, it will move this. Later temp will be moved to the temp will be moved to the next node, that is node C. Now it will check whether temp of data is equal to 47. Yes, the temp of data is equal to 47. So yes, it is. Now what it will do, immediately 47, so temp is here, so temp is here, previous is here, previous is pointing to node B and temp is pointing to node C. Now what you have to do, step you observe, previous of next is equal to temp of next. So temp of next is what? Null. So previous of next, that is this, you moved on to null. It is automatically moved to the null. So it is moved to the null, and after this what it will do, so free temp, so free temp, so temp is freed. So this is the first operation, second operation is freeing up. So like this, when it is the last node is deleted, before that the previous node's next is moved on to null. So what happens, the resulting linked list becomes like this. Resulting linked list becomes like this. So this is the code, this is the operation, this is the action that is happening. So obviously you need not have to return the temp head node. It is already it is a pointer to pointer. And display function, what happens, you have a head node, and until head node is not equal to null, so keep on displaying the data, node data, and once it is done, display the current node. What happens, node moves to the next node. This process will be executed until you reach the null, and finally you display the null, so that you get the linked list appearance. Once it is done, now in the main function, what do you do? Insert 12. So when you say insert 12, what happens? A node is inserted like this. So first node 12 is inserted, and you can see 12 is inserted like this. So it is inserted. Now next 16 you are passing. So as you pass 16, what happens? 16 again goes to the beginning. 16 goes to the beginning, and the linked list appears like this. 16. Next you are trying to print 21. So 20. So 20 goes to the beginning, and you can see, so it is available like this. So as you are trying to insert 24, 24 goes to the beginning and inserted. So same way you insert 30. So what happens, 30 is inserted in the beginning, 30 is inserted, and you can see that. So 30 is inserted in the beginning, so that is done. So it is done, and of course next 22. So 22 is inserted, and in the beginning, and rest the linked list is available. So this is the procedure. It is inserted, and after this you display head node. So that means this entire 22, 30, 24, 20, 16, 12 null is displayed. So this is displayed, and once it is displayed, now you are trying to delete 22. 22 means the beginning, first node, the first node you are trying to delete. So you are trying to delete the first node. So what happens, it moves the head node to 33 and deletes the 22. So after deletion, so what happens, display. So 22 is deleted, so you get only 30 is available. Now after this, you're trying to delete 20. 20 is present at the beginning. You can see it, temp node starts from 30. 30 is not equal to 20, so it will move here. 24 is not equal to 20, so previous node is moved to 30, and current node. So current node, that is temp node, moves to 20 and previous node moves to 24. So the previous node is moved on to 24, previous node, and the temp node is moved on to 20. Now temp of data is equal to 20. Yes, it is true. So what happens? So previous of next is equal to temp of next. So there is a link created between these two, and remove temp. So temp is automatically removed. So there is a link created and temp is removed. So, and after this, you can certainly have a display like this. So the linked list is displayed here. So after deleting, it is displayed. Now you're trying to delete 12. So 12 is present here. Now it starts, the temp node starts from here, T. Whether temp of data is equal to 12? No. So what happens? Previous node will be moved here, and temp node goes to the next cell. So is T of, that is temp of data, is equal to 12? No. So what happens? Previous node is moved here, and temp node moves to the next. So is temp of data is equal to 12? No. Previous node is moved here, and temp data goes, temp pointer moves to the next node. Is temp node data is equal to 12? Yes. So in that case, what it will do, point the previous node of next is equal to null. So this automatically points to the null, and delete the temp. It is done. So this is how it looks. So, and after this, the entire linked list appears like this. The entire linked list appear like this. So this is how. So you have deleted the beginning node, you have deleted the in-between node, you have deleted the last node. So this particular example will show you all the 3 node scenario, deletion scenario. So let us execute this program. Okay. So to execute, either you can scan this particular QR code, or you can just click on this link. So link I have given. So even in the notes, I think probably you might have seen. So you have to just scan it. So as soon as you scan, automatically the link is taken to the program where you can just execute. So that is the thing. So it is moving. I think yeah, it is opening. We can certainly, our IDE I can certainly open. Yeah, so it is still moving, IDE. So I can certainly open here, and which is already there. Yeah, it is opened, you can see. So I can just bring that here for your appearance. So same program, you just see. Yeah, same program. I have insert node, delete node, it is there, same, and display and main, same. As soon as I run this code, so what happens? You can just see, first 12 is inserted. 12 is inserted first. Next 16 is inserted. Of course, insertion is the beginning. Insertion function inserts at the beginning. Next 20 is inserted. Next 24. Next 30. Next 22. After that, what you are doing? You are trying to display. Okay, the entire thing is displayed. Next 22, you are trying to delete it. So 22 is present in the beginning, it is deleted, and of course yeah, so I can certainly put a display function here, so in between, so that you can easily understand display function. Yeah, display function, I can put it after every delete. So 22, if it is deleted, so what happens, let us rerun the code, since I have, yeah, after deleting the 22, what happens, so 22 is gone, so 30 becomes the head node, 30 to 12, so all the node elements are available. Now we are trying to delete 20, so 20 is available in between, so 20 is deleted, and 30, 24, 16, 12 is available. Next, you are trying to delete the last node, that is deleting the element at the end. You are trying to delete, look at here, so 12 you are trying to delete, and finally you got the linked list. So in this particular example, I have demonstrated deletion of beginning node, deletion of ending node, and deletion of in between node. So the same program you can certainly practice. So remember, these programs you need to practice, you need to understand why you are writing each line, and you have to practice. So without practice, absolutely this subject becomes Greek and Latin very difficult. So that is my concern, and try to understand, right? And moving further, so searching operation is very simple. What you are trying to do is you are traversing the entire linked list sequentially, starting from first node you traverse, and it is only one directional. Remember, from first node, if you go to second node, you cannot come back. Second to first, you cannot come back. You have to move again further in only one direction. Return the location of the searched node as soon as the element is found. And finally, if it is not found anywhere, and the temp node reached the null, so what happens? You display the failure notification if the entire list traversed without any match. So it is one thing that you should understand. And the code appears like this. So you are passing a head node here, head node, and you are passing a searching element. You are using flag just to understand whether the element is found or not, and you are using position if the element is found. So that you have to understand. If flag is for checking whether the element is found or not, pose is the position if it is found. So you create a while loop until the node reaches the null. Every time you check node data is equal to element. If it is equal, so what you do? You display that particular element, searching element is found in such and such position. So initially position will be 0, and it will display that element is whatever you are searching, it is found in this particular position. You are just displaying, and make the flag as 1. You break means once you come out of this loop. So if it is not found, if the element is not equal, so what do? You move the node to the next node and increase the position. So 0 position, if it is not equal, so not found, move to the next position. Next 1 position, if it is not equal, go to the second position. Next 3rd position, next 4th position, like this. Move until you reach either the end of the node or end of the linked list, or until you find the element. So once it is found, you display the message and you come back, and you observe the status of flag. If the flag is equal to 0, then you immediately display a message, printf, the element is not found. You can just display. Instead of using flag also, you can certainly check is the node, if it is equal to null. So you understand, when node has reached the end, and since it has not found any element, So you can certainly display. So instead of flag is equal to 0, you can also write whether node is equal to null. So that is also there. So this is how you had to find the linked list element. You have to search it. The same program I can certainly show you the demonstration. So you can certainly see the demonstration. So as soon as I execute this, it is available. You can see the program is available and it is loaded, and the same thing. So you have first insertion, first you create the linked list, next you search for the element. So if it is found, it will display found. If it is not found, it will display not found, and display all the linked list elements. Okay, now you try to insert 12, you try to insert 16, 22, 24, 30 and 22. So you run it. So first you insert the linked list elements, all the elements. So inserted, all the elements you got inserted. So it is C, and you display. So 22, 30, 24, 20, 16, 12, null. Now you are trying to search for 22. 22 is present in the first position itself. Yes, it is found in 0 position. Next, 12. 12, next you pass 99. 99, it will search first, second, third, fourth, fifth, sixth, seventh, last position. No, element is not at all found. So you display a message, element not found. Next you pass 12. So keep on searching until you get an element. Yes, you found the element. So it is 12. So 12 is found in 5. You can certainly do it. So same way. So same thing, I can certainly search another element if you want. So in between the first element 22, I have searched the last element. Suppose I want to search for an element which is 20. So I look for an element which is in between 20, or let me ask 24. So try to run it. So as soon as I run this code, what happens? It will display. Yeah. So 22 is found at 0, 12 is found at 5th position, and 24 is found at the second position, 0, 1, 2. So it is just like that. So every time you are traversing. So that's the program logic, and that's all for today's class. In the next class, we'll discuss about circular linked list. So thank you. All the class recordings are available in this particular website. Stay safe. Have a wonderful day.